Hey there, macro folks. This is Mr. Hooker, and this is video 2 of income and expenditures. So let's get on to it. So, more about the consumption function. So, if MPC, marginal propensity to consume, that is the change in consumption divided by the change in disposable income, and we multiply both sides of the equation by disposable income, we get MPC times disposable income equals change in consumption. So in other words, when disposable income goes up by $1, consumption goes up by MPC times $1. That's the whole point. And so what we're looking to happen, come on, work with me, not against me. All right. So what we're looking for is the idea that A is the autonomous consumer spending by the household, which is the value of consumption when disposable income is zero. It's basically, what you're going to spend no matter what your income is, right? It's your vertical intercept, and MPC is the slope of your consumption function. So as I said when I first showed you this formula, it is the slope of a line. It's a very familiar formula for a lot of people. The letters are different, but the formula is very familiar for a lot of folks. And so there's our slope right there, slope of the MPC. So C is equal to A plus MPC times YD. It's, you know, A plus BY is what it is for a lot of people. So fitting it to the data, according to the data, autonomous spending is around 21,622. The MPC is about 0.58 in America. So the consumption function fit to that data is 21,622 plus 0.58 times YD. And it looks like what you see down there, going on up, way on up, out and out. So disposable income on out to 200,000, consumer spending on up to about 140,000. So there you go. Um, your aggregate consumption function is just putting bigger numbers in it. The relationship for the economy as a whole between aggregate disposable income and aggregate consumer spending is C is equal to A plus MPC plus YD. Same form as the consumption function. Now we're just making everything aggregate. Remember, aggregate is the whole sum of, so it's not just one thing, but taking everything and lumping them together, adding them all together. So not one good, but all goods. So assume that aggregate consumer spending equals 5,000 when aggregate disposable income is zero, and when disposable income increases from 300 to 400, consumer income spending increases by $70. What's the equation for the aggregate consumption function? So there you look down, um, and what you're going to see is there at C, C is equal to 5,000 plus 0.7 YD, and that is it. All right. Shifts to the aggregate consumption function. The aggregate consumption function shows the relationship between disposable income and consumer spending, all else being equal. So if the other things change, and those other things are those things in GDP, by the way, if you just want to know what that is, it's all GDP stuff, right? C plus I plus G plus NX, or X plus M, right? Or X minus M, excuse me. Um, so if any of that changes, then this is going to shift. Uh, so you've got the aggregate consumer function. If there's a downward shift to the aggregate consumer function, bam, we got it. Or an upward shift. There's the upward shift, there's the downward shift. All that means is something happened to consumer spending, something happened to investment spending. Uh, so all of those kinds of things that would change disposable income. Uh, because all of that flows down to people. So if firms don't have money, and here's if you're wondering like how do all the other pieces of GDP flow down to consumer spending, right? And mostly it's the firms kind of thing. But if the firms don't have the money to produce things, they're not going to hire as many people, and if they don't hire people, they're going to lay people off, and that causes income to fall. If it's a great year, they're going to hire more people, and that causes income to rise. So, and basically, the one truth you can always count on in life, if there is money in people's pockets, they are going to try to spend it. So that is what's going on with that. So changes in expected future disposable income, consumer spending depends on the income people expect to have over the long term. Uh, so it depends on the income people expect to have. So rather than on their current income, and that's the permanent income hypothesis. So expectations of higher incomes leads to consumer spending and shifting the aggregate consumption function up. Changes in aggregate wealth. People plan their spending, try to smooth out their consumption. People really like the idea that they know how much they're going to make. I mean, I've spent most of my life getting paid a month at a time, every month. I mean, now I get paid every twice a month, but most of my life I just got paid once a month. Early in my life, I've owned my own business, never knew how much I was going to make in a given month. It's flippin' scary. Um, so people do like that idea that, hey, I'm going to have X amount of money each month. You can plan everything you're going to do by that. Um, and doing that over the years, I've just asked for all my bills to be like in the first 10 days. And then I know by the 12th how much money I have for the rest of the month. Like all my bills are paid. This is what I got left for the month. For the most part, there's a few bills that won't do that. So for the most part, I know like, hey, other than about $300, this is what I got left. So, um, so that's basically doing that. So that's basically the life cycle hypothesis. Um, so the rise in aggregate wealth that way, because of booming stock market, increases the aggregate autonomous consumer spending, shifting the aggregate consumption function up. Also, if the stock market busts, um, people freak out. They start acting like they're poor. Even though they're not pulling that money out today, they act like they just lost tons of money. And so they act poor. I mean, the stock market will come back, but it's really funny how people act about that stuff. So here, panel A here on the left shows aggregate data on disposable income and consumer spending from 29 to 41, um, with a simple linear consumption function fitted on the data pretty well. B shows the aggregate consumption function shifted up after World War II because consumers grew increasingly confident that an economic boom would continue and wealth was steadily increasing. So after World War II, people believed, hey, I'm always going to be better off, so I'm just going to start consuming more and more, and we're just going to continue to do that. Some people will say that that maybe has gotten out of hand in the past 30, 40, 50 years. Um, Others will say it's just a continuation of what it has always been, or what it has been since the 80s. But a lot of people will say that since the 80s, this has gotten out of hand. Like the 80s just set off a time bomb, and this has just gone crazy since then. So, yes, you can blame my generation. That was my generation that set that bomb. You're welcome. Um, Investment spending, it's small but powerful, much smaller than consumer spending, basically tends to drive the booms and busts business cycle. All the recent recessions basically do that. Firms, we talk about everybody being risk averse, and firms are much more risk averse than the average bear. So if anything seems to go wrong, they just like pull up the sidewalk and take their bat ball glove and go home. And this causes what you see here with a bunch of downward things on investment spending. So consumption in the purple and investment spending in the orange. And that basically is all these recent recessions and such. So planned investment spending is the investment spending that businesses intend to undertake. It depends on the interest rate, the expected real GDP, future real GDP, and the current level of production capacity. So do I have the capacity to do more? That's a thing. Is the interest rate low enough that I can make money? So I need to know, like, can I make a good return on this investment? Because if the interest rate is 15%, I got no shot at making a return. If it's 12%, I don't have a really good shot at making a return. And is the GDP heading up, or is it heading down, or is it just like rolling even? If it's heading up, I got a really good shot at hitting something, and we're in good shape. If it's heading down, life's not going to be good for me, and I probably don't want to borrow money right now. So that's the thing. Even though I'm borrowing money for 30 years, I don't want to borrow it now if it's going down. I'd rather borrow at the bottom at very low rates and then like ride those rates for 30 years. So that becomes a thing as well. Firms with investment spending projects, you know, only go ahead with the project if expect the rate of return higher than the cost of the project. Happens on a regular basis. If the interest rate goes up, fewer projects pass that test, and investment spending goes low. This is why I say firms are much more risk averse than the average bear. Conversely, lower interest rates make some investment projects more profitable and more projects get funded. Um, if firms pay for projects out of retained earnings, which is past profits used to finance investment spending, the trade-off is the same because they have to consider the opportunity cost of the funds. There is no such thing as free money, people. So even if they're using their own funds, they will put an interest rate on those funds. Like how much money could they have earned on those funds? They will look at that. So expected future real GDP, all that stuff. If your firm has capacity and it doesn't expect sales to increase, its investment's going to be lower. So there is a capacity load that you really want to hit. So really you want to be below 90%, but greater than 85%. So somewhere between 85 and 90. If you have to be a little above 90, that's fine, but you don't want to be at 95. Um, so there you go. Other things equal, the higher the current capacity, the lower the investment spending. You just can't do it. According to the accelerator principle, the higher the rate of growth in real GDP leads to higher planned investment, and lower rate of growth in GDP leads to lower planned investment. So inventories and unplanned investment spending. So inventory is just how much goods you have to satisfy future sales. So how much do I have on hand in the warehouse? If I go out in the warehouse and I start counting, what am I going to get to? What number am I going to hit? Inventory investments, the value of the change in total inventories held in the economy during a given period. Unplanned inventory investment are the unplanned changes in inventories that occur when actual sales are more or less than businesses expected. So here's the way this goes. Um, Actual investment spending is the sum, to that. So in any period, investments equal to unplanned plus planned. Um, so always, savings is equal to actual investment. At equilibrium, savings is equal to, in, you know, uh, planned investment, which means at equilibrium, say actual investment equals planned investment. So that's what we're looking for is those times where actual investment equals planned investment, that would be an equilibrium point. Okay. So the IE or income expenditure model, we're going to take a detailed look at how changes in spending get multiplied, and we'll have that multiplier we looked at last video kick in on that in multiple rounds in real GDP. We'll go through that and see how all of that happens. And inventory plays a role in that. So basically, we'll have all of that happen. So let's stop here and we'll get back into it right here with the assumptions.